All right, before we move on to Continental, I forgot, I do have a slope controller system. And you'll notice that there's only two controllers. We have the pressure relief, which is not, it's just a pop-off valve. And then we have the slope controller, which is connected to
upper deck and manifold.
upper deck manifold.
Oh, yeah.
It's got two manifolds?
Yeah, it's got both of them.
No,
Oh, it's just-
the throttle's right there.
Oh, okay, yeah, yeah.
This is the oil line.
Yeah.
Okay? Otherwise, it's the same thing.
So that is
Very simplistic.
Isn't that the same as
that looks just like a differential, though. Not.
Told you.
not-
Yeah, it's the
That's
differential.
what I said. It's like a differential.
That is all it is.
I wanted to sort of-
Well, it doesn't necessarily have to be
Slope
all it
the
is.
difference.
Okay, so obviously it's connected across the two, and if you look at the system, where's my density controller? I'm just saying that I could see how it wouldn't be terribly difficult to incorporate because you're sensing this the upper deck anyway. You can incorporate something in there
Yeah.
to do absolute.
Yeah.
Okay. But thus the name slope, and you'll see in a minute why I say that. So, okay. Moving on. Slope controller. All right, let's talk about TCM. TCM systems. I have what, 40 minutes to do this? All right, so typical. I can just write fast and talk fast because that always works really well. The typical system uses 3 controllers. And wouldn't it be nice if they're exactly the same?
They're not.
We have an absolute pressure controller. What do you think that's like?
Density controller?
Okay, I like that.
Sounds a little bit like
Constant
pressure
pressure?
relief valve, too, though.
Little bit.
A rate of change controller.
Kind of sounds like differential.
You think it sounds okay? And then a pressure ratio controller.
Never mind.
So yeah, absolute pressure controller sounds like a density. Pressure ratio sounds like differential. Rate of change controller is exactly what it sounds like. It monitors the rate of change. And so what it's looking for, if you have a significant rate of change, in other words, it sees that the upper deck pressure is here and it is really going up fast, it kind of senses that and says, wait a minute, I'm not going to be able to control this here in a minute, so let's just slow that down right now. Let's put a stop to this nonsense before it gets out of control. And that's what that does. It's exactly what the tag on the top says. Stop this nonsense before it gets out. Okay. All controllers are vented to upper deck. Vented? I don't know if I like that word, but we could probably say sense, but I'll use vented. Vented to upper deck pressure. There we go, UDP. Write that, saving some time. See the world. Get to the end of this lecture. Okay. All controllers operate to either restrict or bleed off oil. To restrict or bleed off oil from wastegate, just like the Lycoming, or Lycoming if you prefer. Hey, let's talk about the absolute pressure controller. Should we look at a picture?
Yes.
Yep, that was it. Okay, there's your picture.
Cool.
Okay.
All right.
Much round.
Air inlet,
Mhm.
13.9 inches is what I believe they're trying to tell us right there. Is compressed.
The deck
Upper
pressure.
deck is now 30.5. I don't think these numbers are going to mean anything to us. Without the throttle, you have a loss on this side, engine, turbine, exhaust gas, wastegate, same thing. Engine oil pressure comes in, more oil pressure pushes on this and closes the wastegate, which means more turbo, or it bleeds off. So we're just going to have down here, the pressure ratio controller, which, like I said, actually, well, it's like that. Pressure ratio controller is connected to
Oil,
ambient
ambient.
and upper deck. Notice it in this diagram, nothing is actually set to manifold lightning. B is the rate of change controller, which I said just senses the rate at which it is changing, just like the name. If your rate is changing too fast, it means your turbo is really spinning rapidly. The pressure is rising too fast, and you're going to overshoot or overboost. So you don't want that. And C, which is the absolute pressure controller, which is like the density controller, just up here at
Measures
upper deck.
pressure.
Yep. So this one is measuring ambient instead of manifold. And so, yeah.
So if B is checking rate of change, how is it doing that if it's only directed with upper deck?
Oh, it
How is
knows. If it's got mechanisms in there. Well, I'll look at it this way. If somebody told me I had to design something like this, what would I make it? You know, and I was thinking, what do I already know? And so I would go to, we have a thing in our aircraft that's called a VSI, vertical speed indicator. And you have inside of there a bellows with a very tiny leak. And so whenever you change altitude, it wants to equalize. And so, but it takes a while to equalize. And that the fact that you've changed altitude makes the bellows expand or contract, which is attached to a needle. And so like it expand and go like this, but then you stop going up and it equalizes.
Okay.
All right, so I think I could probably make something like that with this. Just using a bellows and a calibrated leak. If it's rising too fast, then it would lift the pin up, lift up a little bit. But if it got too much, it'll bleed off and start closing down. I think, well, I could make an analog, something like that. Instead of having a differential, we have an ambient. And what it's doing here is, remember C typically is absolute. I want absolute out of this, right? If you're telling me I want 40 inches, then give me my 40 inches and it'll stop it. Well, one of the problems with that is at some point 40 inches is a little excessive because you have a differential between what is in the manifold and outside the manifold. And that's where they do it here with the Continental, is to watch that. If you have too much of a change, then you can kind of predict, well, that means we're compressing air at this rate, it's going to be this hot, it's not going to be what we want. So we don't want the air in the upper deck to be X number of inches of manifold or mercury, PSI if you will. We don't want what's in the upper deck to exceed a certain difference between what's outside of it. That made sense, I hope. Kind of like, I don't know if you had a tank of air or something, you read the PSI gauge on it. It's the difference between what's in it and what's out of it. It's the same thing. They were very concerned about what's inside versus what's outside. If you want to think about it this way, if the pressure in the manifold or say upper deck exceeds a certain limit, you're going to blow hoses off. And then you've lost everything. So you could look at it that way and go, okay, I can see why you'd want that. Let's see what my notes have to say. Absolute pressure controller. Absolutely controls the design to limit. You just stretch them back there?
No, I have a question about the oil passages that are route to route.
Yeah.
Because if you block off C, that doesn't really do anything, it still goes to the engine. If you block off B, still doesn't do anything, it goes to the engine.
Okay, so remember that if they're all blocked, I remember having a problem with this one. Two engine.
Which it has that arrow coming back.
Yeah, I want to say there was, this goes this way, and this way, and to this way, and this way, because I don't think this arrow is correct necessarily, because,
It doesn't look correct.
yeah, I think there was a problem with that arrow. So engine oil is this way, so we're just looking for, because it'll go this way,
Yeah.
and bleed out that way. It can go this way, bleed out that way. It can go this way and bleed out that way. There is, in fact, 3 different ways through. It's just, I think they've screwed up with their little drawing. So, come this way
That arrow down probably meant to go all the way over.
and bleed out that way. There's one. We could go this way, up,
Could you also just recirculate?
bleed out that way. And yeah, I don't think it's going to do that though.
Yeah.
Or we could go this way and bleed out that way. Oops, it goes that way. So I see 3 ways. It's this arrow right here, I think, is incorrect.
I think it's supposed to go one over to the green.
Yeah. Not uncommon to see errors like that.
So, but you have to block all 3 for the flow to stop the pace.
Yes, and that's exactly what you want.
Okay, there we go.
Turbo, that means turbo on.
So
Turbo on.
to block all 3, would you just block that one passage?
No, each one is an independent controller.
Okay, so you would
Yeah.
just block,
Yeah,
okay.
You want that. You want all 3. They're in parallel. Every one of them gets a say. It's a committee. So all 3 have to agree for the turbo to be fully on and closed. If any one of the committee doesn't like it, they can open the wastegate. Upper deck, let me see, absolute pressure controller, designed to limit. Max upper deck pressure. Max upper deck pressure. I don't have to write that. Well, at a set limit, it will bleed off oil from the wastegate. Yeah, I think we're good there. Yeah, I think that works right there. Designed to limit max upper deck pressure. Let's keep it simple. Rate of change controller. Rate of change. It's not really that this system is that much easier. It's just you understand that much already and I don't have to explain so much. Senses the rate at which upper deck pressure increases. So senses the rate at which upper deck pressure increases. I'm out of paper.
So you can't take any more notes.
No, you don't have to. Okay, so this is kind of still continuing where if rate is too fast, valve opens and bleeds off oil, which opens the wastegate. The pressure I'm having a little problem here. Pressure ratio controller.
That was the one that was connected to ambient.
Mm-hmm.
Ambient in upper deck.
At higher altitudes, turbo must work extra hard to keep manifold pressure set for max horsepower. So at higher altitudes, turbo must work extra hard. Turbo must work extra hard to keep manifold pressure set for max horsepower. Set for max horsepower.
Basically just saying that you need more air in order to keep the same pressure.
Yeah. So at some point, this air is going to become too hot, which will cause detonation, right?
Yes.
Okay. At some point, air is too hot and will cause detonation. guess that was an A. This is a B. The pressure ratio controller, PRC, pressure ratio controller, will keep this from happening. So it does that by, again, sensing the ambient pressure around it, saying, wait a minute, so if my ambient pressure is, I'm trying to think of a number, we're at 29 here, well, 15 inches, I'm just throwing out numbers, but it's at 15 inches or 10 inches, and we are very, very high, and to try and keep 40 inches in this is going to be excessive, and the engineers have figured out that's too much of a ratio, this is working too hard, this is, so we'll start backing off a little bit on that, start opening it up and saying, okay, you're working hard enough, you're done, you're good. This is point 2. Monitors the ratio between upper deck pressure and ambient. So, monitors the ratio between upper deck pressure and ambient pressure. Limits upper deck pressure to 2.2 times ambient. Got that? All right, let's go through the operation. I won't have time to write everything I'm going to say here, so you may have to take some side notes.
Test on Monday?
What?
Test on Monday?
No, tomorrow. That would put me behind, and then you'd have...
Oh no, that's terrifying.
All right, operation. Engine off. Wastegate spring-loaded to the open position. Same thing, right? Nothing's changed? Okay, wastegate open position. Turbo is? Off. Come on, everybody's got to engage here.
Yes.
Okay. At least be like Tobias. Just throw out something so I know you're alive, man.
It's 50-50.
I know. Huh?
Fine, but all right.
All right. When engine is started, oil pressure sent to the wastegate. Oil pressure sent to the wastegate.
Closes it.
All right. Wastegate closes and spools up the turbo.
Turn the turbo on.
All right, turbo on. Upper deck pressure and manifold pressure increase until, which one's going to kick in first?
Upper deck
Upper
pressure.
deck pressure.
Until pressure ratio, rate of change, or absolute.
Absolute.
Rate of change. Rate of change.
Okay. Rate of change isn't going to activate unless the turbo is really spinning up fast.
The pressure ratio.
Well, it's going from nothing to something.
Yeah, but if you're idling, it's not going to.
Okay.
Probably.
You need to get your absolute first.
Okay, so absolute. So upper deck pressure and manifold pressure increase until absolute pressure controller opens. So first thing is going to be absolute pressure. C is going to open.
Oil flows
Okay, so
that way.
flows that way.
Oil flows that way, draining off. Drip, drip, drip. And it's what it does. It just goes overboard too. So you got to carry a lot of oil with you. That's the bitch of this system. Don't. That's not true. Okay. I was writing it down. Okay. So that will start fluctuating and keeping this at the appropriate spot. All right. Now the opened absolute pressure controller bleeds off oil and wastegate, causing turbo to slow and stabilize upper deck pressure. If upper deck pressure increases at a rate of more than 6.5 inches of mercury, Hg, per second, then which one's going to open? The rate of change. So if it's more than that, rate of change will open. Bleeding off oil and
Lower lowering the
Lowering the turbo.
Opening the wastegate and slowing the turbo. This prevents what?
Overboost.
Overboost or
Bootlegging.
overshoot. Okay, at about 16,000 feet, which one is going to start
Pressure rate.
get?
Hey.
Pressure ratio.
Okay, on one left, pressure ratio controller starts to unseat.
So that's only at 16,000 feet. Anywhere in between there, it is completely closed.
Should be closed and fine.
So a pressure ratio controller would be for an engine that's going to be turbo normalized.
Be for any of them. Still have that. Because 16,000, yeah, it could work for any of them. All right. This is kind of a side note here. So which you should know this one, if the fuel injection, and which fuel injection system we'd have?
Continental RSA.
Continental RSA. He is half right.
Continental fuel injection.
Yeah.
How you did? Say those, can't do
That's the book photos.
If the fuel injection system uses a variable orifice fuel pump, what is going to vary the orifice? Throw something out. A what?
Air pressure.
Flow divider.
Yeah.
The
Okay, fuel injection system variable. Where's the orifice located in the pump? What do we call that?
the pressure relief valve.
Nope, that's low end.
Maybe
High end adjustable orifice. Okay, if it uses a variable orifice, did you guys have variable orifice on yours?
Nope.
I think most of them did not. Here's a variable orifice. A fuel pump. The variable orifice has an aneroid in it.
Oh, who?
what?
An Android?
Yeah, one of the robot guys. It has an aneroid, bellows,
It's contagious.
Okay, chip bag.
a chip bag
Okay.
connected to it, which goes to upper deck pressure. So if it uses something like that, it's kind of it's sensing what the turbo's doing. So low manifold pressure will reduce the fuel flow. So reduce the fuel flow, that means low manifold pressure would have a small or big orifice.
Small.
Big
Big.
orifice.
It would
Big
be
orifice.
bigger. It would let more fuel flow.
Sorry.
Okay?
That.
And then as the turbo, so I add throttle, air comes rushing in, engine speeds up, but yet the turbo is lagging on me, so I don't have a good solid amount of manifold pressure. It's kind of, more ambient. Got to wait for everything to spool up. So I have to wait a second to give it the fuel to match what it's going to have. So tie that into a bellows with that orifice, and then as soon as we get turbo pressure on, then the bellows can, turbo pressure is going to make it shrink because of the pressure, so it'd be an inverted needle, right? And so it would then start blocking off some of the orifice, causing more fuel to go to the fuel control unit. Follow? Because everything's backwards a little bit. Okay. Variable fuel pump, low manifold pressure will reduce fuel flow. Low manifold pressure will reduce fuel flow during acceleration. Until manifold pressure, MP, is increased. This prevents an overly rich mixture due to turbo lag. Okay, other TCM systems.
That system you just described is part of the TCM, right?
Fuel injection system. Yeah, it's on the fuel injection pump for the TCM, because we're all in TCM right now. So other TCM systems. Well, I just gave you the main one with the 3 controllers. There's another one that uses a variable absolute controller. That one's pretty easy to talk about. Combines all 3. All 3 into 1 unit. So it's got the rate of change.
I was just wondering what
No.
Bravo was.
There, I don't know, there's no B.
It's alright. No.
It was operation. Operation. Let's see. Variable 1, 2 combines all 3. Uses a cam operated by throttle. Sound familiar?
Yep.
To vary spring pressure, I just put this. Use a cam operated by throttle. That's like the Lycoming. Which one? Variable. Like the Lycoming variable. Usually used in conjunction. Used with. Let's say with. Simple. An overboost relief valve. Which is a spring-loaded poppet valve. That vents upper deck pressure. That vents upper deck pressure if it is, we'll say, too high or exceeds set limits. And they also, and this will piss you off a little bit, use something called a slope controller. And this one references upper deck pressure and manifold pressure. Oh, does that sound so familiar?
Upper deck manifold pressure.
To maintain a set differential across what? Across the throttle. All right, everybody's good?
Almost.
That was a lot, and I only have 3 pages left, so.
Wait, so both the typical system and the variable absolute controller use the 3 controllers?
No, the variable absolute combines all 3 into 1 unit.
Okay, so.
But yes, they're all 3, but it has just 1.
Okay, so the typical system will have 1 of the 3.
Typical system has 3 of 3.
Okay,
It's like the picture.
okay. I was just making
Picture.
sure that,
3 of 3.
okay.
1, 2, 3. This is typical.
But it's just not one system, it's 3 individual modules.
3 individual modules.
Gotcha.
And then if you use
That
the
one has
variable
all those
absolute,
3 modules in one module.
1 module, but you can differentiate because it has the cam operated thing on it. And an overboost next to it, which is just the pop-off valve like Lycoming it kept showing you. All right, let's see. Moving on.
To the east,
Well, I had a little thing here to kind of bring it all back around. Let me just confuse you. Density review. Density senses upper. Nah, we don't want to do that. It takes much time. There it is. And then we talked about intercoolers a little bit.
Ouch.
Intercoolers. Got to watch your intercoolers.
Oh.
Can't be smashing the vent fins over. Did you ever see anybody who wants to pressure wash their radiators? Yeah. So if these get damaged, you gotta either go in there and straighten out all the fins, little tiny screwdriver or something. Which is so. Areas of damage to left intercooler found STD 1820 rocker box cover screw loose in this area. So rocker box screw bouncing around in there and did that. So we gotta watch those intercoolers. Mouse milk is the preferred lubricant for.
Oh, so that's real.
What's that? Yeah, it's a real thing. Got to move this up a little bit. There we go.
Right, I made that one.
There we go. All right. So it's the preferred lubricant. And on any turbocharged system, I'll take some of this mouse milk penetrating oil and definitely lubricate around the wastegate, especially because wastegates, they take a beating. You know, it's if you've ever worked around any exhaust system, you know you can't even pull the exhaust nuts off. You know, that's why professionals use a Sawzall to get your catalytic converter out.
Lawrence knows that.
Yes, I do too. So, all right, so mouse milk. So, mouse milk with the mouse, that's the lubricant that you're going to want. And I do it on every annual on turbocharged engines and really lubricate that wastegate so it works nice and fluid, all the fittings around it. And so, mouse milk, and we're going to write that down. Is there something? Wow, okay, I feel like there's something. The other thing, and I can't believe I don't have I know somewhere I have a slide. I thought it was in here, but it's not. And that is also on annual inspections. What I'll do is I'll get in there, and I like to take off the inlet to the compressor and look in there for FOD damage and run it with my fingers, feel in there, make sure it spins nice and free, doesn't get all, stiff in some spot. And yeah, I had a really good picture. There was a wrench stuck in a turbine. I forget where it is. It's like, let me see. Maintenance. Use mouse milk on wastegate to dissolve the coke. Do not adjust controllers without exact instructions. Keep the induction clamps tight. Look for leaks. Check the fins on the intercooler. Check rotables for damage. Talked about the V-band clamps. Pressurization. Where do you get your pressurization from?
The outlet of your
Turbo, but what does it go through first to limit? Sonic the Hedgehog Venturi. Pressurization. Pressurized aircraft use upper deck pressure for cabin pressurization. Use of Sonic Venturi limits the amount of air taken in for pressurization. Upper deck pressure also is used to pressurize magnetos. Forgot to mention that. So if you have a turbocharged engine, there's a really good chance you'll have pressurized magnetos. And you just take upper deck pressure and you take out the vent plugs and you put a little fitting right there.
Okay.
Yeah, and then the other plugs have a little bit smaller holes in it, so you pressurize the magnetos.
What's the advantage of that?
Okay, so air is the insulator in a magneto,
Oh, okay.
which keeps the spark going where it's supposed to.
Yeah.
You remove the insulator, spark can go anywhere it wants to, right? So you pressurize it to add the insulation back in to keep the sparks going where they're supposed to go.
That's nice. So it's able to fly at higher altitudes if you have that.
Yes, otherwise you start getting flasher over and they don't work well. And you guys don't know Juan, which is unfortunate. He was one of the students who graduated right after COVID, but he has flown around the world in his Bonanza. Literally, I mean, he goes to England in his Bonanza. Been to South America.
That's crazy.
And I think he was a ferry pilot or a pilot for Bonanza. So he's got some really interesting stories, but his airplane is so nice. Oh my gosh. It's a G1000 Bonanza. But anyway, he talks about he was over, I think, the Atlantic Ocean, and the gauges are just going off the chart. Things are happening bad. It started misfiring all over the place, and I guess he's wearing one of those survival suits. Yeah, survival suit, because you go in the Atlantic. And so it's, I'm talking about the orange suits and stuff, and I think you have to wear it around your waist, or he does, but he'll take his arms out. So I mean, he's getting the suit on and he's zipping up, and this thing's just dropping. And he got down to a couple thousand feet, and boom, started working just fine. So
Magnetos.
yeah, because it was a normally aspirated engine. Let's see. I'm going to throw this in here. This is called the Power Recovery Turbine, the PRT. PRT, Power Recovery Turbine. Well, this is going to sound like really stupid old technology. Apparently, it's coming back around in decent trucks. Now, some of the old guys, I've heard them call it a parts recovery turbine because they were so prone to problems, you could just find the engine parts laying in here. But you can see what it's doing. We have a crankshaft, and of course it shows like it has one cylinder because it's a radial engine, which is only one throw. But you've got it a direct drive shaft, but it does have a fluid coupling, so it kind of runs this way through the fluid coupling and then a smaller shaft back out. Follow that? So this shaft turns, this gear turns this shaft turns the coupling. The coupling then turns another shaft that is inside of this, so it comes out here. Okay,
Like
so
a miniature reduction gear.
yeah, it's just I think fluid, like a clutch, like a automatic transmission. The what do you call that? The torque converter. Like that's what I can picture it as. All right, so that then turns this, which turns this gear, which then turns this right here. Except this isn't turning this; it's a turbine, which means that the exhaust gases flow through here, which turn the turbine, which turn the shaft, which turn the gear, which turns the fluid coupling, which adds power back into this gear, which is
adding power back to your crank.
yes.
That's weird.
But I heard they're, like I said, very problematic. Let me see. Also called a turbo compound engine. You may want to write that down. Turbo compound engine, because it is called that. Uses a turbine wheel driven by exhaust gas that directly connects to the crankshaft. Just after World War II, the Wright R3350 18-cylinder aircraft engine used 3 turbines to recover 20% of the exhaust energy in a Douglas DC-7 and Lockheed Super Constellation airliners. Early designs were a failure and called parts recovery turbine by the mechanics. Auto manufacturers are looking to revitalize this concept. Detroit Diesel uses a flywheel turbine on the DD-15 to add 50 horsepower and improve economy by 5%. Volkswagen has done them one better by removing all of the exhaust components and no, just kidding. And I read somewhere Ferrari was using one to drive a generator that electrically powered the wheels. They called their a motor generator heat unit, which was interesting.
Woo!